Good afternoon, everybody. This session the topic of the session is the improvement of water quality. And we have quite several speakers that will take part of it. I'll start the session off by giving you some feedback on the work that was done during task 5.1 of the Vertinova project. And then Peter Prince will continue with giving you his insights, especially focusing on open fields water and his work that he's doing there. And then we have Raul Kanu, and which will share his research, and Gonzalo Gutierrez. Thanks. Okay, so I have the privilege to share with you the technologies that was exchanged during task 5.1 in terms of preparation of water. So preparation of water is a bit of a broader subject. It includes also storage and not only quality improvement of water. So we discuss the storage of water, exactly the question of how much should be stored, depending on your requirements and the weather conditions. And then problems, and in this case it was algae bloom, which is a problem in terms of storage of water. And then in terms of water quality, we looked at one aspect of that, and that is where growers reuse water, the accumulation of sodium, and what technologies can actually assist us in solving that. The benchmark report highlighted the importance of the problem in terms of algae bloom. If you look at the blue, it is growers that report in the way that they use, irrespective of the type of water that they reuse, that most of them, the biggest problem that they experienced was algae bloom in the storage of the water. So we felt that was, based on that information, important that we look in different solutions for growers on doing that. Yeah, I've got very limited time, so a lot of the details is not going to be covered in this talk, but we'll just give you some feedback on what was done. So in Belgium, there was different covers tested, especially since it is well known that if you cover a storage of water, there will be no algae growth, but it's not done, and that's purely because of costs. So cheaper ways of covering the ponds and so on was investigated. And the one was using different types of sheets, and the other one is this hexagonal floating cover, which fit into each other and then will give you some cover. It was also, there was some biological control also tested, and that is in Poland, where there was a bacteria which was feeding on the algae, and in that way was reducing the algae concentration. So this is how it looked like before they started adding the bacteria, and 6 weeks later, this is how it looked like. So you can see there is a visual improvement in the water quality in terms of algae growth. It was, this is still ongoing because there's also analysis of the water and so on being done. Then the benchmark study also, the benchmark report also highlighted quite an interesting thing in terms of recirculation of growers. There was 2 questions asked to growers. The one was asked, growers were asked how much water do they reuse, and then a follow-up question, how much do they discharge? And if you look at these, the red square or the red section in each of the two graphs, there's quite a good correlation between those two questions. It was clear the guys that say they don't reuse, they're also about the same that answered the question that they discharge on a daily basis. But what was very interesting was on the question for the number of the same two questions, but those that answered that they reuse 100% of their water, compared to those that answer that they never discharge, there was a marked difference in the number of people that answered it that way. So about more than 40% of the growers said that they recirculate 100% of their water, which should mean they discharge. More than 40% of the growers must also say they never discharge anything. But only 8% of the growers said that they discharge never, which means that it shows that the way that the growers look at the discharge of that small amount of water that they need to discharge just shows you that they still think that they don't see it actually as discharging anything. Which shows us that there is still a large gap between, if you look at, this, there's still a large gap of growers that current technology is not sufficient to help them to reach that ultimate goal of not discharging anything. This technology was showcased in the Netherlands and in Belgium. And typically what you will have is that a grower that are recirculating a certain percentage of his water is coming from the drain water that he's reusing. And then he will get some good quality rainwater collected from the roof of his greenhouse. And then the rest is desalinated water, and then he makes up the rest with fertilizer to give a optimum nutrient mixture to the plants. Now, the two sources of sodium going into the greenhouse is the desalinated water. There's also always a little bit of sodium still left in the water, and then also fertilizer that contains some sodium. So after a while, it is necessary for the grower to, the sodium concentration, because of the recirculation, the sodium concentration reaches a level which it will have a negative impact on production, and then they have to discharge the sodium. But with the discharging of the sodium, they also discharge nitrate and phosphate, which is now the regulations on that is becoming more and more stringent. So what we did was we put in this sodium reduction unit. And instead of discharging the water, we put the sodium reduction, a certain amount of water, 900 liters per hectare per day, through the SRU. And what the SRU does, it separates the sodium with the other cations from the nitrate and the phosphate. And so you get 100% recovery of nitrate and phosphate back into the drain water. And then you remove the sodium from the unit, and the ratio is that for every 900 liters of water that you treat, you make 45 liters per day per hectare of concentrate. The idea is to remove daily just as much sodium which is coming in from these two sources. And that way, you then keep your sodium concentration in the drain water constant. This was very successfully demonstrated over a period of a season. The year was 2017. So the blue dots and the blue line give you an idea of what the concentration in the sodium concentration in the drain water was the previous season. And the grower had to ensure that the level does not increase beyond the point that he did not want it. He had to discharge 1,000 cubic meters during the season of 2016 to maintain the concentration at that level. And then with the SRU, these red dots, you can see that we had a constant decrease up to this point where the grower then decided not to run the machine anymore because he did not like the sodium level to go too low. But there was no discharge of nitrate or phosphate containing drain water during that year. Unfortunately, we then were told that we are not allowed to discharge the concentrate which contains the sodium, and the demonstration was discontinued. And it took us quite a couple of months to find a solution, but we are happy to report that we have now managed to get a company which will take the concentrate and dispose of it. They are a waste collecting company. They've got specifications in terms of how much chloride they can handle and so on. So it will then require a concentrate step to concentrate the 45 liters to 9 liters per day per hectare. But because of the low volumes, it is fairly, it can be done cost effectively, which means that in the end, to get rid of your sodium without discharging it into the environment, but you can discharge it legally, is costing about 500 euros a year per hectare. Then last but not least, it was the water dimensioning tool. That is about the volume of water, how much water you need to store to ensure that you have water available if you collect rainwater. This was showcased from Belgium to France and Spain and the UK. And it's all about making sure that you have sufficient water storage based on the water that you will collect from the rain. Thank you. So now, Peter, if you can...